Hi everyone, welcome to the interview series episode 3. So today's the topic is decision trees. Interviewers love to ask questions on decision trees. So today we have Radha here to answer all our questions on decision trees. Hi Radha,
Hi Deepthi. Hi everyone. So, what questions do you have for me today?
I have noted a lot of questions, so I'll quickly start with the basic question. What is entropy?
Okay. So, entropy is a measure of impurity within a data set. Its formula can be given by minus sigma p log p to the base 2, and it is summed over all the classes.
Perfect. So the base 2 is important. A lot of people miss it, but yeah, you have accurately mentioned. So how do you interpret this entropy values?
Okay. So, low entropy signifies a data set where the data points are similar or belong to a same class, indicating a high homogeneity, whereas high entropy signifies a data set which have diverse data points belonging to different classes, indicating high heterogeneity.
Okay. So what are the range of values for entropy?
Okay. So, the minimum value is 0. The maximum entropy for k classes is log 2 k to the base 2, where k represents the number of classes. For example, if you have 4 classes, the maximum entropy would be log 4 to the base 2, which is 2.
Okay. So it depends on the number of classes. Right.
Yeah.
So log k to the base 2k is number of classes. Okay. What is information gain?
So, information gain is a measure of how much impurity is reduced by splitting the data on a particular feature. It is calculated by subtracting the weighted average entropy of the child nodes from the entropy of parent nodes.
Hmm. Correct. So is there any problem with this information gain?
Yeah, the gain criterion tends to favor attributes with many possible values. One such situation is when you have an ID attribute, we consider using the ID attribute to partition the data. Each training sample will form a subset, but it has only one class, right? So, which results the entropy of child nodes is equal to 0, hence maximizing the gain, but ideally it's useless for partition.
True, true. So ID column is generally is of no use. In case people are using it and using information gain as a metric, then surely it will go wrong. So yeah, we generally remove these ID attributes, but as you mentioned, if at all you have attributes with a higher number of values, then yeah, it will go wrong. So is there any solution for this?
Yes, there is something called gain ratio, which reduces the gain by a factor which is proportional to the number of possible values of the attribute. So, if the possible number of values are high, the gain is reduced by a higher factor. And this factor is the entropy of the data with respect to the values of attribute.
Okay, so based on the entropy of the data with respect to the values, so you try to reduce your gain.
Yeah,
Okay, this way, as the number of possible values increases, your factor to reduce will also increase.
yes,
Great.
exactly.
So, can you please explain in detail about the decision tree algorithm?
Yeah. So decision tree algorithm starts with a root node where we evaluate all the attributes with a metric like information gain or gain ratio. We choose the attribute that provides the highest gain, and this becomes the root of the tree. From there, the data set is split based on the values of the selected attribute, and the same process is applied recursively on each subset. At every step, we continue selecting the attribute that maximizes the gain, forming out new decision nodes. The recursion stops based on predefined stopping criteria. For example, if the information gain falls below a given threshold, or if a maximum tree depth is reached, or if we reached a limit on the number of leaf nodes, or if the node is already pure. I mean, the examples are only from one class. So the final leaf nodes represent the predicted class. If a node isn't pure, the majority class among the remaining samples is assigned as the label to that leaf.
Correct, exactly. So, whatever stopping criteria that you have mentioned, so what the maximum depth or number of leaf nodes or the threshold, all these are the parameters in the decision tree implementation where we can use. Okay. Do you know what is tree pruning and what is the significance of tree pruning?
Yeah. So to reduce the overfitting in context of decision tree learning, pruning is used to simplify the model by replacing the deep subtrees with leaf nodes. There are two methods. One is pre-pruning, which is also called as early stopping, and post-pruning, that is removing the branches of after the full growth of the tree. So post pruning is preferred as if it evaluates the error at each node and prunes subtrees that don't improve the accuracy, which leads to a better generalization.
Hmm. Exactly. So as we know, Dacian trees are prone to overfitting. So doing this tree pruning will help us better generalization. Great. So it's intuitive that Dacian trees handle discrete variables. It's very intuitive, but how does it handle continuous variables?
Yeah, for continuous variables, decision tree handles it by finding a threshold which splits the data into two intervals. It evaluates all possible thresholds based on assorting unique values in the data and selects the one which gives maximum information gain or gain ratio. Unlike discrete attributes, continuous attributes can be reused at multiple tree levels at different splits.
So that last point is very important. It has to be underlined. So yeah, if you see discrete variables are used only once in the entire tree, but continuous variables can be used multiple times with different thresholds. Great.
Yeah.
So how do you handle missing values?
So there are various ways to handle. First thing is we'll replace the missing discrete values with the most frequent category or with the mean for continuous attributes. We can add unknown token as one of the value for discrete variables as well. And the second thing is at a tree node, if the training example has a missing value for splitting the attribute, it is distributed proportionally across all the branches based on the distribution of known values in the training data.
Yeah, so there are various ways to handle the missing values, but it depends on your data and the use case that you
Yeah.
handle. So, do you think we can use imbalanced data set on a Dacian tree?
Yes, you can apply, but the model's performance may suffer, especially in terms of predicting the minority class accurately, because decision trees aim to maximize overall accuracy or information gain. In imbalanced data, the majority class dominates, so the tree might bias towards the majority and ignore the minority class patterns. As a result, the tree may achieve a higher accuracy, but a poor recall or precision for the minority class.
Okay, true. Then how do we handle it?
So the first way is resampling the data. We'll have to either oversample the minority class or undersample the majority class. And the second thing is use class weights. There is a something called a class weight parameter in the decision tree implementation
Mm.
to penalize the misclassification of the minority class more.
So people has to remember this that whenever they're using imbalanced data, so be careful while applying Bayesian trees. It has few problems. Either do oversampling or undersampling, or do some apply some class weights. So what is oversampling? What are the various techniques of oversampling?
Okay, so the goal of oversampling is to balance the data set by increasing the number of samples in the minority class. So the most common oversampling techniques are random oversampling and smooth.
Yeah. So can you explain more about this random oversampling and smart?
So random oversampling is simply duplicating examples from the minority class, whereas smooth stands for synthetic minority oversampling technique. So it creates synthetic samples of the minority class using interpolation between nearest neighbors,
Hmm.
and it's more robust than simple duplication.
True, true. So can you explain in detail the process of smart?
Yeah, sure. So let's pick a minority class sample X and we'll find its k nearest neighbors.
Mm,
Usually it's taken as 5 from the same class.
mm,
We'll choose one random neighbor from them. Let's say it as X neighbor. we'll create a synthetic point between x and x neighbor using interpolation.
Mm.
Now this x new is equal to x plus lambda times x neighbor minus x. Lambda is a random number ranging between 0 to 1, where 0 is not included. And then we'll repeat all the above steps to generate as many synthetic samples as needed.
Okay, great. So what is undersampling and what are the various techniques of undersampling?
So instead of adding more data to the minority class like oversampling, undersampling removes the data from the majority class.
Mm.
Okay, so the most common undersampling techniques are random undersampling and ENN, edited nearest neighbors.
Okay, can you explain random sampling and ENN?
So random undersampling is randomly removing examples from the majority class, and ENN is in ENN will consider for each sample in the dataset the k nearest neighbors excluding the sample. If the class of the sample disagrees with the majority class of its neighbors, we'll remove the sample from the dataset.
Mm.
And this process typically affects the majority class samples more because they dominate and are more likely to overlap with the minority samples.
Okay, so whatever the SMOT, ENN that you have mentioned, so these are the most common oversampling and undersampling techniques. There are others as well. There are variants of SMOT as well, like borderline SMOT, Addison. So there are multiple variations of these as well. So based on my experience, a hybrid works really well. Like SMOT plus ENN works really well. For me, it has given the maximum accuracy. Uh, Compared to just using oversampling or just using undersampling. Using hybrid methods works well. So that's great, Radha. Thank you so much for answering all our questions. And thank you, guys. Happy learning.
Thank you, everyone. Happy learning.
Mhm.